Now let us consider another interesting problem where we have got a regular hexagon A, B, C, D, E, F and a body is placed at the center. Body is P. Now we want to find what is the force on this one when we keep one body, two bodies, three bodies, four bodies, five bodies, six bodies at these six corners. We'll consider one after the other. First of all, let us keep only one body. Suppose this one figure I am using for all the options. Okay. For option 1, only one body placed at A. When only one body is present, you forget that these bodies are not present. Only one force will be there, F from P to A. This is equal to GMM by distance is how much? A, length of the side, A square. Now we are keeping two bodies, A and B. Two bodies can be kept on adjacent corners, two bodies can be kept on alternate corners, two bodies can be kept on opposite corners. Suppose first of all they are kept at the adjacent corners A and B. Then there will be two forces. One is towards A, another towards B. These forces make an angle 60 degrees. We know that when two equal forces act at 60 degrees, the resultant is root 3 times one of them. So the answer is root 3 gm square by A square. Now, same two bodies are kept at alternate corners A and C. So there are two forces FPA and FAC. FPA and FAC, they are making 120 degrees. Whenever two forces act at 120 degrees, we know that the resultant is equal to one of them. The basic formula for this one is F dash is equal to 2F cos of theta by 2. This formula we use. So if it is 120 degrees means 120 by 2 is 60, cos 60 is half, half into 2 will get cancelled, F dash is equal to F. So here the answer is equal to just F, which is gm square by A square. Now the two bodies are kept at opposite corners A and D. Then two forces will be there, one from P to A, another from P to D, one from P to A, another from P to D. These two forces are equal and in opposite directions, so they will cancel each other. So the body at P, the body P will remain at rest. The resultant force on it is 0. After considering two forces, two bodies, let us consider three bodies. Three bodies can be kept in different ways. First one, they are kept on adjacent corners A, B and C. When they are kept on adjacent corners A, B and C, the effective forces will be FPA, FPB and FPC. FPA, FPB and FPC. Out of this, FPA and FPC act at 120 degrees. The resultant is equal to F. Then that F is in this direction of FBP, so that will also get added. So you will be having 2F. So the resultant force is 2 gm square by A square. Suppose these three bodies are kept at A, B and D. A, B, not C and D. Then in that case this force and this force will get cancelled. Only one force will remain. The forces are FPA plus FPB plus FPD. Out of this, FPA and FPD will get cancelled because they are in opposite directions. Only FPB is there. That's equal to gm square by A square. Suppose we have kept three bodies at A, C and E. Means A, C and E, alternate corners. When they are kept at alternate corners, we are getting three forces. Acting like this. This we know that the sum of these two forces will be equal to F in this direction. That F and this F will get cancelled. The resultant is 0. After that we are trying with four bodies. Four bodies are kept at A, B, C, D. When they are kept at A, B, C, D, there are four forces FPA, FPB, FPC, FPD. Out of this one, two will get cancelled. FPA and FPD will get cancelled. PA and PD will get cancelled. What remains? FPB and FPC will remain. PB and PC, the angle between them is 60 degrees. Therefore, the resultant is root 3 times gm square by A square. Now we are keeping five bodies at the five corners of a regular hexagon. Suppose the bodies are placed at A, B, C, D, E. Then there will be five forces FPA, FPB, FPC, FPD, FPE. FPA and FPD will get cancelled. P and PD will get cancelled. FPB and FPE will get cancelled. PB and PE will get cancelled. What remains? Only one force remains. So it is Gm square by A square. Suppose we have placed 6 bodies at all these 6 corners. Then there will be 6 forces. Then you can see that there are 6 forces forming 3 pairs acting in opposite directions. PA and PD will get cancelled. PB and PE will get cancelled. PC and PF will get cancelled. Therefore, the resultant force on the body at the center is 0. Now you can see one more thing here. When only one body is present, the force is Gm square by A square. When 5 bodies are present, only one is missing, then also the force is Gm square by A square. That means in a hexagon, either you keep one corner occupied or one corner vacant and all the other corners occupied. The answer is same. Then one more thing we have seen that if 4 bodies are present, this answer is same as when only 2 bodies are present. If 2 bodies are present at the adjacent corners, or if 2 adjacent corners are vacant and all the remaining corners are occupied by bodies, the answer is same, root 3 Gm square by A square. I hope the answer is very clear to you. After this, we'll take up one more very simple problem, last one. In this one, it is asked many times. It is very simple problem. Almost 95% of the students will be knowing this answer because it was asked many times. The problem is we have got a body of mass capital M. We have divided into 2 segments and placed at a certain distance. How it should be divided such that the force between them is maximum. Okay, let us consider that.